Okay, in this presentation we are going to look at probability distributions. In particular, what we're going to do is look at the uniform distribution, and more exactly the continuous uniform distribution. Now this is very useful in a lot of applications, particularly if you're a computer science student or something like that, because the uniform distribution does have a lot of practical applications in computer science. Also in statistics, also and stuff like that. But anyway, I digress. Suppose a continuous uniform random variable x has the following parameters. So the uniform distribution is characterized by an upper bound or an upper limit and a lower limit. Simple as that. It's a very straightforward one, really. Okay. Really, the point of the uniform distribution is actually just to learn about probability distributions and continuous probability distributions, just as a sort of a warm-up, essentially, before you get into more challenging ones such as the normal distribution. Anyway, what we could say is x is a uniform random variable with parameter a, which is the lower bound, with here it's equal to 1 and the upper bound equal to 9. So a and b is the upper and lower bound. So what is the probability of x being between 5 and 8? What is the probability of x being greater than 7.2? And what is the expected value of x and the variance of x? So part A, what is the probability of x being between 5 and 8? So essentially it's this interval here. Okay. So what is the probability of x being between 5 and 8? Just as a sort of quick remark, the continuous uniform distribution is a continuous, the uniform distribution is a continuous distribution, so that expression there is more or less mathematically equivalent to this. Okay. The less than or equal to is more or less the same as the less than sign when you're dealing with continuous distributions. The difference is so trivial that it's not worth talking about. So what we're going to state, anyway, going back to our interval, is we're going to state our lower bound is L is 5 and our upper bound U is 8. So for the uniform distribution, now that's U here is the upper bound of an interval, so it's not an expression of anything to do with the name of the distribution in this instance. Okay, it can be a little bit confusing, but anyway, it's just so lower and upper bound. Okay, so essentially how to calculate that is more or less fairly intuitive, to be honest with you, but if you want a sort of formal approach here, or a sort of codified approach, it's the upper bound minus the lower bound divided by b minus a, which is the range between the upper bound and the lower bound, essentially. So it's the range of the interval divided by the range of the entire range of possible values. So here what we're interested in is the probability of x being greater than or equal to 5 but less than or equal to 8. So the upper bound u is 8, the lower bound is 5, and b minus a is 9 minus 1. So essentially what we have there is 3 divided by 8, which is 0.375. If you think about it, that's fairly intuitive, really, actually. So you almost don't really need this formula for it, but it's good to have all the same. So here we have the second question. I just paused it very quickly so I can correct a mistake there. I forgot to update some numbers. Anyway, what is the probability of x being greater than 7.2? Now, essentially what we're asking here is what is the probability of x being between 7.2 and 9, because really it cannot go outside that range of values. So again, the lower bound here is 7.2, and in this case the upper bound here is 9. So essentially the probability of x being greater than or equal to 2 is the same as the probability of x being between 7.2 and 9. So we approached it the same way, and essentially what we have here is what is the probability of x being between 7.2 and 9. I forgot that there. That is 9 minus 7.2 divided by 9 minus 1, which is 1.8 divided by 8, and that gives us an answer of 0.225. And finally, the last part, what is the expected value of the continuous uniform distribution, denoted E of x? So essentially what we do is we use this formula here. Now something that throws people is that you have a plus here. It sort of makes sense when you think about it. So b plus a divided by 2. Okay, so for this worked example, the expected value of x is 9 plus 1 divided by 2, which is 10 divided by 2, which is 5. Okay, which is halfway between 9 and 1. Okay, the variance of the continuous uniform distribution, denoted var of x, is computed using this formula here. B minus a squared divided by 12. Okay, so just watch out for that. There's a plus there. B plus a divided by 2. B minus a squared divided by 12. So there we go. For this worked example, the variance is the variance of x, 9 minus 2 squared divided by 12. That's 8 squared divided by 12. 64 divided by 12, which is 5.33. Okay. Now, these are probably formulas that you'll have to remember in your exam. Luckily, hopefully that you might have them in the back of your exam paper. But honestly, the uniform distribution is sort of straightforward enough. So hope they'll give you this probably just to make it a little bit harder.